Okay, we're going to begin our next chapter, chapter 8. And throughout chapter 8, what we're going to be dealing with are rational numbers and rational expressions. And we're going to have to first learn in section 8.1 how to simplify, as well as we're going to take a look at multiplying and dividing rational expressions and rational numbers. Well, first let's recall what's meant by a rational number. Okay, when we are talking about a rational number, we're talking about numbers like, for example, 2/5, or for example, 7/2. Okay, what we have here are two examples of rational numbers. Okay, fractional numbers basically. And if numbers can be rational, we can also have rational expressions. And let me show you what an example of what a rational expression would look like. A rational expression would take the form of maybe 2 over x plus 6. Or we could have maybe x plus 5 over x minus 3. Or we could have maybe x squared minus 1 over x squared minus 2x plus 3. So here we have some examples of rational expressions. And basically what's going to make an expression rational is when we have some algebraic expression found within our denominators. Okay? A rational number is simply a numerical fraction. When we are talking about a rational expression, we're talking about an algebraic fraction, particularly one where we have some type of algebraic expression in our denominators. And when you first learned about numerical fractions, you were always told to simplify your numbers. Okay, and the same is going to be true when we are dealing with rational expressions. And here's where that idea of factoring, okay, we spent a great deal of time in chapter 7 talking about how to factor down polynomials. And here we're going to continue to use that skill of factoring. Remember, I told you it was one of the most important skills. We're going to continue to use that skill of factoring throughout chapter 8 as well. And when we simplify your rational expression, what we're going to have to try to use is what we call the fundamental principle of fractions. And it's with this fundamental principle of fractions that will give us the opportunity to simplify your rational expressions. And this is what the fundamental principle of fractions tells us. A times k over b times k. Well, let's take a look at what's going on here. We have the quantity A times the quantity k over the quantity B times the same quantity k. And if we have the same quantity k in the numerator and the denominator, and they are being multiplied, we can in fact simplify that expression, because any quantity divided by itself when they are being multiplied can simplify to the form of 1, and that would leave us with simply now A over B. And this would be considered your simplified form. Okay? Back in the day, we said that you reduced the fraction. Okay, but technically you're not reducing the fraction. It is an equivalent fraction. You're not making the overall number smaller. You're making the number on the top and the number in the bottom smaller, and that's why we would tend to use that word that you are reducing. But a better word to use would be that you have simplified your fraction. For example, let's say we had the fraction 24/36. Here we have a numerical fraction, a rational number, and we want to simplify this. What we're going to do is we're going to come up with factors of 24 and factors of 36. And we're going to try to find a greatest common factor between those two numbers. And so the number 24, the factors that I would use would be 2 times 12, because 2 times 12 is 24. 36 I want to write as the factors of 3 times 12. And now, because of this fundamental principle of fractions, I have a 12 in the numerator, and I also have a 12 in the denominator. They are being multiplied, and now we can further simplify using this fundamental principle of fractions to the equivalent number of 2/3. 2/3 would be your simplified number of 24/36. They are equivalent numbers, they are the same quantity, but the 2/3 has just been simplified. Okay? And that's what we're going to be looking to do as well with our rational expressions. For example, if we had 6x minus 12 over 7x minus 14. Okay, now what we're going to look to do is to simplify this rational expression. Well, here's where the factoring comes into play. Remember your steps to factoring. Your first step was to put your polynomial in descending order. Step 2, you want your leading coefficients to be positive. Step 3, recall, that's when we look to see if there's a greatest common factor. If it's a 4-term, we would factor by grouping. We then went to the 5th step, which was to factor down any trinomials. And then finally, of course, the 6th step was to factor down those binomials. So now that we have recalled those steps to factoring, I'm going to look at the numerator and the denominator independently, and I want to factor them down. Well, in the numerator, I could factor out a greatest common factor of 6. And if I factor out the 6 from these two terms, we are left with, of course, an x minus 2. So the numerator is now in factored form. And now we have to do the same thing with the denominator. In looking at my denominator, I too can factor out a common factor of 7. And if I factor out the 7 from these two terms, I would be left with an x minus 2. After we are done factoring as much as possible, that's when you look to use this fundamental principle of fractions. It is very important. We are looking to see, do we have a same factor in the numerator and denominator that's being multiplied? And looking here, we sure enough do. The x minus 2 can be found in the numerator as well as in the denominator, and it's being multiplied, so we can in fact simplify this rational expression to just 6/7. And that would be your simplified rational expression. Let's try another one. Let's say we have x squared plus 3x plus 2 over x squared minus 1. Well, the first thing that we're going to have to look to do is to factor the numerator and the denominator independently. Okay? So in my numerator, I have a trinomial. I'm going to set up my parentheses. Factors of x squared, that would be x and x. What do I know about my signs? I look here. The fact that it's a plus sign, I know it's going to be the same sign. I need two positive numbers, here and here. Now, of course, remember, with factoring, we want two numbers that multiply to 2, that add up to 3, and of course that would be 2 and 1. Now let's take a look at the denominator. The denominator is a binomial, and we can factor down this binomial in that it's the difference of two perfect squares. For that, recall we had a formula, x and x. We know we're going to have different signs, plus and minus, and the factors of 1 would have to be 1 and 1. Now that we have the fully factored form, of our algebraic fractions, that's when we look to utilize that fundamental principle of fractions. We're looking to see, do we have the same factor in the numerator and the denominator that's being multiplied? Well, we notice, looking at our factored form, that we have an x plus 1 on the top, as well as we have an x plus 1 in the denominator, and they are being multiplied. So we can, in fact, simplify, leaving us now with just an x plus 2 on the numerator and an x minus 1 in the denominator, and that would be your simplified rational expression. Okay? Let's try a harder one. Once again, you will be asked to simplify your rational expression. Let's say we have a 3x squared minus 2x minus 1 over 2x squared minus 6x plus 4. Now, there's a lot going on here, all right? Why don't you pause the video for a moment, try performing the factoring on this particular rational expression, the numerator and the denominator, and then see if anything simplifies, okay, because it's the same factor in the numerator and the denominator. When you're done, turn the video back on and let's see how you made out. Well, from a factoring point of view, if we were to factor this numerator, we would have to have a 3x and an x. We're going to need to have different signs. I'm going to put a plus 1 here, minus 1 here, and of course the factors would have to be 1 and 1. Now the denominator, okay, before I do anything with the denominator, I want to initially factor out a common factor of 2. And if I take out the common factor of 2, I would have an x squared minus 3x plus 2. And now this is factorable. I still have the 2. I set up my parentheses. And now factors of x squared, x and x. Now we're looking at the same sign, 2 negatives. And of course the factors of 2 would have to be 2 and 1. And now, once again, now that we have our fully factored form, the factoring is probably the hardest part of the problem, okay? That's why you want to be very confident in your factoring skills. Now that we have the factored form, we use that fundamental principle of fractions, and we look to see if there's anything that's the same top and bottom. And so we have an x minus 1 in the numerator and an x minus 1 in the denominator. That can be simplified. So our simplified rational expression would be a 3x plus 1 on the top and a 2 times x minus 2 in the denominator. That is your simplified expression. What some people like to do, you don't have to, but some people distribute the 2 in which case you would have had a 3x plus 1 on the top, and you would have then had a 2x minus 4 in the bottom. That is also an acceptable answer. But I always say, quit while you're ahead and leave your answer in fully factored form. You don't have to distribute the denominator, but some people like to, okay? Let's try another one. Be careful here. Once again, remember we're looking to simplify your rational expression. Let's say we have 5 minus x over a 2x minus 10. Let's take a look here to see what's going on. Well, first of all, in the numerator, I'm going to have to perform step 1 because my numerator of x minus 5 is not in descending order. Okay, so I'm going to change up the order. I'm going to write this as a negative x plus 5 over 2x minus 10. Also now, going back up into the numerator, My leading coefficient is not positive. It's a negative 1. So what I want to do is factor out a negative 1, and that would now leave us with an x minus 5. The numerator now is in fully factored form. The denominator has a greatest common factor, a common factor of 2. So let's factor it out. If I factor out the 2 from these two terms, you're left with x minus 5. And now that we have the fully factored form of our algebraic fraction, we look to see if we can utilize that fundamental principle of fractions. Do we have a common factor, the same factor in the numerator and denominator, being multiplied? And we do. We have an x minus 5 on the top, and we have an x minus 5 in the bottom, so they can be simplified. And that's why we would have an answer of a negative 1/2 as our simplified rational expression. Okay. So when you simplify, your rational expressions, you want to take a look at the numerator and the denominator independently. And then, of course, you look to see, after you're done factoring, if you can simplify because you have a common factor in the numerator and denominator. Now, after you learned how to simplify numerical fractions, you began to learn how to perform the 4 basic operations: add, subtract, multiply, and divide. Well, here in section 8.1, we also have to address how to multiply and divide rational expressions. So we're going to have to review that first of all. We want to take a look at how we're going to multiply and divide rational expressions. And as always, you want to express your answer in simplest form. Let's say we had the following. Let's take 12 25ths, and we want to multiply it with 5/4. Now, probably when you first learned how to multiply these numerical fractions, you learned 2 ways. You could just multiply numerator with numerator and denominator with denominator. And if we were to multiply 12 times 5, that would give us 60. 25 times the 4 in the denominator we would also multiply, giving us, of course, 100. And so now we have our multiplication done. But now you have to simplify this fraction. You want to simplify your answer. And so how can we simplify 60 over 100? Well, let's do like we did in our very first example of 24/36. I'm going to take the number 60 and I'm going to factor it down into, let's say, 3 times 20. And the number 100, I will factor it down into 5 times 20. And now that we have a common factor of 20 in the numerator and denominator being multiplied, we can in fact simplify this fraction to the numerical value of 3/5. Okay? That's one way how we can multiply rational expressions, where you multiply numerator with numerator and denominator with denominator. Or, let's take the same example, 12 25ths, multiply it with 5/4. Well, let's say we don't want to multiply first. Let's do some factoring first. The number 12 I might think of as 3 times 4. The number 25 I could think of as 5 times 5 times. The number 5 I'm going to leave it alone. And the number 4 I will also leave alone. So we did some factoring first. And now let's use our fundamental principle of fractions. If we have anything that's the same top and bottom, we can simplify. Well, we have a 4 in the numerator and a 4 in the denominator. They simplify. We also have a 5 in the numerator and a 5 in the denominator. They also simplify. There's nothing left to simplify numerator and denominator, So now let's perform the multiplication last. And if we multiply 3 times 1 times 1, you get a 3. If I multiply 5 times 1 times 1, we get a 5. So we get the same solution of 3/5, but doing it a slightly different way. The first way, we did the multiplication first, and then we simplified. The second way, we simplified first, and then you multiplied what was left over. And it's this second approach that we're going to want to use when we multiply rational expressions. For example, let's take 10x plus 20 over 2x squared minus 3x plus 1, and we want to multiply that with x squared minus 1 over a 5x plus 10. We want to multiply these two rational expressions, expressing your answer in simplest form. Now, I would not use the first technique. I would not multiply numerator with numerator and denominator with denominator. That's going to make it more challenging for us. But instead, I will use this second technique, where I'm going to take a look at each numerator and denominator independently and factor them down. So this first numerator of 10x plus 20, if we were to factor it, we can factor out a greatest common factor of 10. By factoring out the 10, you would be left with an x plus 2. Let's take a look at the second numerator. Second numerator isn't too bad. X squared minus 1. That is factorable into an x and an x. Different signs. Factors of 1 would be 1 and 1. The second denominator is also not too bad, because I can factor out a greatest common factor of 5. And if I factor out the 5, I would be left with an x plus 2. It's this first denominator. It's a bit more challenging, okay? But thankfully, I'm comfortable enough with my factoring that I could actually factor it down into a 2x and an x. I know I'm going to need a minus 1 and a minus 1. Now that we have our fully factored form of all the numerators and all the denominators, I'm going to look to utilize that fundamental principle of fractions and see if we can simplify anything that's the same, top and bottom. Well, the x plus 2 and the x plus 2 simplify. The x plus 1 as well as the x minus 1 simplify. Let's take a look at these numbers. 5 will go into 5 once, and 5 goes into 10 2 times. So we are done simplifying things as much as we possibly can. Now we want to multiply whatever's left. So what's left in the numerator, I still have the number 2, as well as I have the factor of x plus 1. So that's what's left in the numerator. In the denominator, the only thing that remains is the 2x minus 1. This would be your simplified answer. Once again, you could, but you don't have to. If you so desire, you could distribute the 2 in. So you could write this as 2x plus 2 over 2x minus 1. That would be a perfectly acceptable answer as well. But once again, I always recommend leaving things well enough and you don't have to do that multiplication. The factored form is usually the preferred form. Let's do one more together involving multiplication. For example, if we have 4x over x squared minus 4 being multiplied with x squared minus 5x plus 6 over 4x squared minus 12x. Once again, we want to perform the multiplication and of course expressing our answer in simplest form. Once again, I would strongly recommend that you do any type of factoring that you possibly can initially. So let's take a look here. I'm going to leave my first numerator of 4x. This first denominator, I recognize it as the difference of two perfect squares. So I'm going to factor it down as such, x and x, plus minus, and factors of the 4, 2 and 2. Now let's work with the second fraction. This is also factorable. The, of course, factors of x squared would be x and x. We're looking at the same sign, both negative. And so now I'm looking for factors of 6 that add up to the 5. So I'm going to go with 3 and 2. Now, as far as this last denominator here, the only thing that I could do from a factoring point of view is I'm going to factor out a common factor of 4x. And if I factor out the 4x from the first term, we get x. And if I factor out x from the second term, we're left with a minus 3. Now that I have the fully factored form of both fractions, both algebraic expressions, once again we look to utilize that fundamental principle of fractions and see if we can simplify. Well, I have the 4 on top, 4 on the bottom, they can simplify. I have an x in the numerator, x in the denominator, they simplify. I have an x minus 3 on the numerator with an x minus 3 in the denominator, they simplify. I also have an x minus 2 in the numerator and in the denominator. But be careful now. Let's take a look to see what remains. In the denominator, I have this algebraic expression of x plus 2. But don't forget, I also have in the numerator the place value of the number 1. So 1 over x plus 2 is your answer to that question. Okay. The last thing that we have to talk about today in section 8.1, of course, would be to divide. If we can multiply rational expressions, we can also divide them. For example, let's just recall how we divided numerical fractions. If we had, let's say, 12 25ths being divided by 3/10, recall what we did. A lot of times students like to remember keep, change, flip. Okay? Sometimes students like to remember keep, change, flip as a way of dividing fractions, because we're going to keep the first fraction. We're not going to do anything with the 12 25ths. We will change the operation of division to multiplication. But then, of course, we have to flip the fraction, the number that happens after the division. And if we flip 3/10, we use the reciprocal of 10/3. Now that we have performed this keep, change, flip, we have changed it from division to multiplication. Now we will proceed to multiply these two fractions. Well, once again, the 12 I could think of as maybe 3 times 4, and the 25 I could think of as 5 times 5. The 10, I will keep that as 2 times 5, and the number 3 I will keep as 3 times 1. And now that we have done all of our factoring, let's see what we can do to simplify. Well, the 5 on the top and bottom simplify. The 3 on the top and bottom simplify. And I believe that's it. So we are left with a 4 times 2, or 8, in the numerator. And the denominator, we are left with simply 5 times the number 1. So 8/5 would be the answer to that original division problem. Okay? So the same would be true, of course, with division of rational expressions. For example, let's take a 3x plus 3 over x squared minus 1, and we're going to divide that by a 5x minus 5 over x squared minus 2x plus 1. Well, before we do any type of factoring, once again, we don't want to forget that we have to do this keep change flip. So I will keep the first fraction of 3x plus 3 over x squared minus 1. I'm going to change it from division to multiplication, and then we have to flip our second fraction. So that's going to give me an x squared minus 2x plus 1 now on the top, and of course the 5x minus 5 on the bottom. Now that we have turned it into a multiplication problem, now of course this is when we need to do that important skill, and we want to now of course factor. So my numerator of 3x plus 3, I'm going to factor out of 3 and leaving me with an x plus 1. The denominator of x squared minus 1 is factorable. It's the difference of two perfect squares, x and x, different signs, 1 and 1. Our second numerator is a nice easy trinomial. Factors would be x and x. Same sign, both minus. And of course, factors of 1 would have to be 1 and 1. The denominator, the second denominator, only has a common factor of 5. And after we factor out the 5, we are left with an x minus 1. This is probably a very important step. Okay, lots of factoring going on here, an essential skill. Now that we have factored things as much as possible, now let's see what we can do to simplify. Anything that's the same, top and bottom being multiplied. Well, I have an x plus 1 on top and bottom. I have an x minus 1 top and bottom, as well as a second x minus 1 top and bottom. Well, what remains? In the numerator is simply the number 3. In our denominator, we have the simple number 5. So this simplifies to 3/5. Let me have you try doing one on your own. For example, x squared minus 8x minus 48 over 7x squared minus 42x is going to be divided by x squared minus 16 over x squared minus 10x plus 24. Pause the video and try this one, and when you are done, turn the video back on and see how you made out as we'll work through it together. Well, the key once again, let's start this problem off right by doing the keep change flip. So I'm going to have x squared minus 8x minus 48 over the 7x squared minus 42x. I'm going to change to multiplication and now use the reciprocal and flip that fraction. X squared minus 10x plus 24 goes on the top, as well as the x squared minus 16 goes into the bottom. Now we have some factoring that we have to perform. This is the very important step. Our first numerator, I'm going to set up my parentheses. Factors of x squared would be x and x. We're talking about different signs. And of course, the factors of the negative 48 that would add up to this negative 8 would give us now a positive 4 and a negative 12. That takes care of the numerator. This denominator has a common factor of the monomial 7x. And if I factor it out of these two terms, you would have an x minus 6. This numerator is also factorable. So let's set up our parentheses. X and x. Here we have the same sign, two negatives. And our factors of 24 that add up to 10 would have to be 6 and 4. And this final denominator is also factorable. It's the difference of two perfect squares, x and x, different signs. And of course, the factors of 16 would be 4 and 4. Well, now that I have my rational expressions in their fully factored form, all I am looking to see is, do I have the same fraction, the same factor in the numerator and the denominator? And sure enough, there are quite a few. I have an x plus 4 on the top and bottom. They simplify. I have an x minus 6 on the top and bottom simplify. As well as I have an x minus 4 on the top and bottom. They too simplify. So what's left over? But an x minus 12 on the top, as well as a 7x in the bottom. That is your simplified answer. Okay? So it's not only important that we perform the division, it's important that our answer is expressed in simplest form. The key underlying component of all these problems is, of course, the factoring. If you need some additional help with that factoring, go back over your skills of factoring in Chapter 7. Okay, it's one of those things that never quite goes away. We will need it a great deal on this test, okay, as well as in future ones as well. Okay, so factoring is essential. Make sure you are confident in your factoring. That completes section 8.1. Okay, in our next lesson, we're going to take a look at how we add and subtract these rational expressions. Those are a bit more complicated, require sometimes a bit more steps. Do try the homework that goes along with section 8.1, and as always, email me any questions or concerns that you may have. Until the next time, be well.